Welcome back, everyone. Now it's exciting time to have this panel discussion with three pretty fascinating men leading the way of this new age space race on our space symposium today, starting with Marc Bell, co-founder and chairman and CEO of Terran Orbital, as well as Declan Ganley, CEO of Rivada Space Networks, and Bulent Altan, co-chief executive officer of Mynaric. Welcome, gentlemen. How you doing today?
Great, thank you. Thank you, Anna.
Good. Happy you're here with us. So we are entering an era of mega constellations that will serve different customer and end market needs. So it doesn't appear to be a winner-take-all market. From the perspective of the panel, what are the key differentiating factors that you believe will determine success? We'll start with you, Declan.
Well, I'm focused on Rivada's success, obviously, and I wish the very best to everybody else. The thing is mega constellations. It's a term that gets used, but they're not all the same. Not all mega constellations are doing the same thing. They're not all serving exactly the same customer. So to talk about others first, something they say you shouldn't do. Say, if you take Starlink or you take Kuiper, they are a consumer-focused, consumer service, best efforts, a bit like your mobile, your cell phone service is a best effort service. What Rivada is building is something very different. The architecture is different. If you take those, even now I can say traditional LEO sat constellations, they're bent pipe in their architecture, meaning you go up to the satellite basically looks for the closest relay station that it can find. It may do a few intra-satellite hops, but then it lands to a relay station and you're back into the internet and into subsea cables, etc. Rivada doesn't do that. Rivada, you go up and we are building a global mesh, sort of think about a fishing net cast around the whole planet. There's 24 orbital planes and they're in polar orbits. Polar orbits make a big difference than elliptical orbits. So some mega constellations are in elliptical orbits, sort of serving the middle part of the planet where most of the people live. There are others, the Rivada being the prime one, that are in polar orbits that can cover every parallel and every square meter of the surface of the planet. And in Rivada's case, what we are doing is building the outer net. So you have the internet that carries all the other traffic and the traffic indeed from the other mega constellations. Rivada is building the outer net. The outer net doesn't have to touch the internet unless it wants to. You go up to the outer net, you stay on it. It's 600 routers that are connected by lasers, a minimum of 4 on each one of those routers. That creates that fishing net effect around the planet, and it gives you the fastest network on the planet with the lowest latency. It gives you very high, unprecedentedly high security. And in Rivada's case, our filing, our spectrum rights, because the Ka band is shared spectrum, we have a very high priority filing. In fact, we're supposed to say this quietly, but it's moving to the de facto #1 filing for a mega constellation, meaning we don't have to do Mother May I to everybody else. Our orbits are at 1,050 kilometers. You can see a lot from up there, meaning we don't need quite as many satellites to have that coverage of the whole planet. And that coupled with priority, it's like having the penthouse suite with an elevator that takes you from the ground up and from the penthouse down, where that elevator is dedicated for your exclusive use. That's what priority is all about. So that's what we're doing. I can't talk as much to what others are doing, but building the outer net for this planet is a good thing, and doing it with Terran Orbital is something that we're excited to be doing, and we're making really solid. It's hard work, but we're making very, very solid and real progress towards the first launch. The first big launch that we're putting up is in April 2025. We have a contract with SpaceX that's already sort of out there to get the first 300 satellites up there on time. and on budget, and working with a satellite manufacturer, a mass manufacturer that's capable of getting the job done for us.
Thank you for that. Gentlemen, feel free to add anything if you like.
Maybe I'll just add on to it a little bit. Given the fact that Declan talked a little bit about that laser link, building that mesh network out in space. There's not that many companies that actually work on that technology. Mynaric being one of them. So we get to play a little bit of in the background of many constellations out there. I think what Declan is showing here, what really is. What we see in our customer base, the differentiator is understanding your end customer and what they're looking for. Communications is not communications. It's not just banging bits to the end customer. Every customer has a complete different stack of requirements, and you have to make sure your network matches that. We allow that backbone to exist, but then there's so many more elements that make up a constellation. A lot of that, for example, is that end user device and that end user experience, the security issues. For example, using laser links like Declan is doing with Rivada, you're never touching the ground. You don't ever present the data in a way that actually can be intercepted by an adversary or anything. So everyone has a little bit more, has a different communication requirement. And what constellations are doing is every single constellation is going for a different slice of it. Sure, there are overlaps between constellations, but we are seeing today multiple constellations going for different customer bases, and they are all viable. At the end of the day, if you look at the last decades, the most incredibly growing human demand has been bandwidth, especially when it was shown by COVID. And I don't think we will ever oversaturate that market. It's also just presenting more and more verticals for people to dominate.
Thank you for that. So third-party estimates call for up to 100,000 satellites in orbit by the end of this decade. So Marc, what percentage of these satellites are for government versus commercial use, and what are some key applications?
So great question. A few weeks ago, General Saltzman, who runs Space Force, was testifying in front of Congress, and Congressman Michael Waltz let the cat out of the bag, and he said publicly that there are applications currently with the FCC here just in the United States alone for 60,000 more satellites to go up into space. But the reality is, you have it's all about the government is a chunk of that, but commercial will dwarf whatever the government's doing. The government today only has 4 to 6% of its needs met from space for the U.S. military that it needs today. And constellations like what Rivada is building will more than supplant what they need. And they want to use more data. You hear them always talking about data as a service, data as a service. I just spent a week in Washington at meetings, and that's all everybody talks about. The U.S. government doesn't want to own satellites anymore. They want to contract out, use commercial constellations, use constellations that can deliver data in a secure fashion that makes it tactically actionable, and that's what makes and there's very few people willing to do that. All the foreign constellations are out the window because it's for the DoD especially, and things like Rivada Space is a huge home run for the Department of Defense.
And Bulent, can you add on to this? How different are the requirements for government versus commercial customers, and what types of communications and applications will be offloaded to commercial constellations?
Overall, we see a certain amount of differences, of course. I think government has a certain amount of strategic interest when they're putting up a constellation. They do want a larger, I want to say, supplier base that can support a constellation. They are very often, when we see in the government constellations, are going for specifications that would actually be dwarfed by any commercial constellations. Today, if I have to give an example of a difference in requirements between government and commercial, if I look at requirements from places like Rivian and other commercial constellations coming to us, they are willing to very often even single source for better capabilities for example, bandwidth. We today have a terminal. We are working on a terabit link between satellites. We already are marketing our 100 gigabit solution, but in the government realm, we are working at the bottom end of the gigabits, so 2.5 gigabits at best between satellites, because there has to be a much wider base requirement that can be served by other companies than just Mynaric. We're realizing that, and then we have to very often have a duality in the company or duality in our product that can serve all of it. And I think the winners are companies like Mynaric, but also Tyvek. I don't want to put any words in Marc's mouth, but I think I see the same thing. Companies that can understand both markets, understand the differences of requirements, but really make a final solution that overlaps both ends of the spectrum. They are the ones that can utilize, I want to say, the high numbers of commercial constellations, bringing down the cost of government constellations. In return, probably take the certain amount of open risk style of something like the Space Development Agency and use the funding that comes through that to prepare the funding and the technologies that are needed to put up constellations like Declan's.
And so how prepared is the satellite industry base and supply chains to support this ramp in demand? And where are the bottlenecks? And how are you each managing risks in your specific area?
I'll go first, but I think we all have something to contribute there. I think the satellite companies and the space supplier base is quite split. There are the ones that I want to say more in the incumbent space industry that go for a let's see what the market demands and then we build capacity approach, which was a healthy approach when projects would take forever and it was mostly government driven and really long cycles. Things would be requested by the industrial base and a factory or a capability or technology development would be done there. I think in the meantime, you have definitely a different set of space companies. Some people refer to that as new space that do the investment, technology development, and investment into production capabilities ahead of market demand, just like any mature industry would do. That requires a certain amount of research and conviction. But for example, in Mynaric, today we have a backlog of more than 300 terminals. But we have already put together a factory that can put out 2,000 terminals a year because we know demand will be coming. And we want to be here when someone writes us a check or gives us a work order just to go ahead and send those terminals. We don't want our customers having to live in fear that we may not succeed in putting up the capability they need. We want to do that with investors' money ahead of time. And we have done that in Mynaric.
I mean, we've seen a huge, the military industrial complex over the past few decades has really been shipped overseas. You see all your chips made overseas, you see components made overseas, and the government's realizing that with the incredible amount of fake Chinese chips floating around the planet, counterfeit chips, that they really need to be made here. Chips need to be made here. Biden passed a $50 billion bill to bring chip manufacturing back, but it's more than that. I mean, so, we always say if you control your supply chain, you control your destiny. And meaning that we manufacture 85% of our components in-house. We just built a state-of-the-art printed circuit board assembly facility. We have a state-of-the-art machine shop with robotics. And the goal is to bring mass manufacturing back into America, but for very high-end, very sophisticated, very technical products like what people here are building today, and to do that on a scale that eventually will help drive down the costs, and then we focus on increasing the functionality as time goes on. So it's really a win-win. It's win-win for the government, it's win-win for the American people, and it's a win-win for companies that are going out there and building new constellations. And it's been, it's an exciting time because you're seeing a whole renaissance go on of people, made in. You used to see all these stickers, "Made in America." They don't see anymore, and people are now focusing "Made in America." Congress is getting the idea that things need to be made in America. I mean, we're a service economy, and we have to go back to being an industrial economy as well.
Declan, do you want to add anything to that?
Yeah, back to your question. I mean, what we did, I actually had a team of the top space engineers from Germany who work for Rivada. They ran the procurement process, a very rigorous one, for over a year to select the vendors and the satellite manufacturers, and we talked to everybody. And we identified those that were that suppliers for satellite manufacturer and for launch that could deliver. That when we did the deep dive and looked into the organizations and how they were set up to be ready to immediately kick into mass manufacturing, and deliver what we needed within our schedule and within our budgets, there was a standout, and that was Terran Orbital, and to their credit, that's not to disparage others who also, the mass manufacturing thing is, you're going to see more of it, and you're going to see it in other places. But we selected the manufacturer that was going to be able to hit our timelines. We had, and it's known, we had an ITU timeline that's associated with our filings, our spectrum rights, etc. We have to make launch by April 2025, and so we gravitated to the most obvious solution that was able to get that done. So those things can, it's there. There's some scarcity at the moment, but that's changing. And again, I can only talk about what Rivada is doing in terms of us fulfilling and achieving our milestones and getting our mission done of getting the Alternet up and running. Those capabilities are in place. You couldn't have done this 5 years ago. You couldn't have done this 3 years ago. It's really interesting that sort of that inflection point that's been crossed, and that's going to be. I just want to add this, not to take up too much time, but there's another inflection point that's been crossed. It's not about these things anymore. It's about the 250 plus other smart things per capita of the world that we're going into that aren't just going to be in heavily populated areas. They're going to be there, but they're going to be everywhere. And ubiquity is hugely important. And if your viewers and listeners do a little bit of research and look at how much traffic, communications traffic, is currently carried over satellite, it's minuscule compared to what's carried over terrestrial networks and the internet. That share of, and that's growing exponentially, but the share of that overall growing pie that's going to move to LEO is, we think, quite substantial because of the need for ubiquity for all of those smart things to be connected seamlessly around the globe with high speed, with security.
Well, you touched upon this, so let's go into it. So much of this growth in unit volumes for satellites by the end of the decade will be in the low Earth orbit. So does LEO get too crowded, and how do constellation operators look to mitigate this issue?
I mean, there's enormous, I hate to explain this, but a lot of space in space. If so, we think about it, the Earth is covered, 60% by water, 40% by land, and you got 3.2 billion cars driving every day, and for the most part, not hitting each other. Space, you also have a lot of Y. And you're on Earth, you have 6 feet of Y, the height of your Chevy Suburban. We got 43,000 miles of Y in space. And you only have like 18,000 objects floating around in space today. So there's an incredible capacity in space, but we're making satellites smarter. So you're going to see us putting together satellites with things like LiDAR in them, that they're going to see another satellite or an object or a screw or a nut coming towards them. They're going to move out of the way, let the object pass, and move back into the position they're supposed to be in. And we're building those technologies today for constellations tomorrow that will allow them to be satellites to be smarter and to think on their own and using AI and not have to worry about someone on the ground. Like today, they have to physically move the ISS out of the way when they see an object coming, and someone has to physically do it. With the satellites of the future, like what's going to be built for Declan, the future will be satellites that will move themselves without human interaction.
Anyone else want to add to that?
Yeah, I think there's also a certain amount of regulatory attention being spent more and more on this. Let's face it, I think both on the commercial and in the government side, a lot of resources are being put forward to do tracking. We're not just talking about satellites, of course. We're talking about a lot of debris, a lot of small little pieces, and knowing where each one of them is getting better and better every day, not just by government entities, but also commercial players. And the combined push of governments to have that capabilities in place is definitely helping satellite operators to do maneuvers more smartly. On top of it comes also the fact that we are looking more and more towards regulatory pressure on satellite operators and builders to outfit their satellites with propulsion systems and maneuverability. I think non-maneuverable satellites will be very soon a thing of the past. And we are going to see more advanced satellites, sensors being one of them, actuators being the other side of it, be part of the constellations. And with that, being able to use all three dimensions of motion, I think the space is, as we say, quite vast. And we will be able to put quite a bit of capability that serves life on the Earth itself up there.
And as Marc alluded to, we're putting in automatic collision avoidance into Rivada's constellation. And Marc also talked about the y-axis, the altitude. I mean, there's a lot of space up there, and we're at 1,050 kilometers. We're not at 350 kilometers, so it's there's less traffic at 1,050 kilometers. You can see a lot more from up there, and that combined with the priority access to the spectrum is important. But that's again not to disparage others serving different needs in different markets. We're focused on being able to provide service level agreements, guaranteed data rates, etc., where not a just sort of best efforts basis. So that's a big differentiator. But automated collision avoidance is going to become, I would expect, the default mode of these types of constellations in the future. And it's not, we have to be. And Rivada today in Egypt, in fact, there's an ITU meeting in Egypt where we've been talking about, our environmental policies, with regard to our how we're managing our constellation and making sure that we don't leave any junk up there floating around indefinitely. We have put in place policies and procedures to make sure that doesn't happen.
So let's talk about launch capacity. It's a question for many industry watchers. We've seen SpaceX execute and turn into the industry leader by a wide margin. So how do you think the broader launch industry matures? Do you think we will still be talking about launch capacity as a bottleneck to deployments in a couple of years? And what needs to happen to change this?
Well, I think that 40-story tall monster that Elon launched the other day is definitely showing people the world is about to change. And everyone's like, oh, it only lasted a few minutes. I'm like, no, it's 40 stories tall. It's a skyscraper they launched. That's called innovation. That's spectacular what SpaceX is doing. And that's going to dramatically change all of our worlds because that'll lower the cost to launch down dramatically, and he's made tremendous progress. And everyone forgets, in the early days of SpaceX, they were blowing up rockets left and right, but nobody remembers that. Today, if you blow up a rocket, everyone's like, oh my God, the world's coming to an end. And that's not true. That's how innovation happens. And so he's really innovating. I give him a lot of credit for what he's accomplishing. It's just amazing, and which affects all of us on this call, what he's doing, because it will lower the cost of launch, which will make whatever we build more accessible to the world.
Anyone else want to add?
We ran a procurement, a whole process to secure launch, and which we did, and we did it with SpaceX. And there is a reason that they're the clear leader in launch in the way that they are. They can get it done. They can get it done at the right price, and they're a proven entity. I mean, everyone looked at the Starship, the 40-story thing. Bet you that either the next time or the time after that thing goes up, it'll go all the way, and they'll figure it out. And that's entrepreneurship. That's America, actually. That's what America does best. It breaks things, it tries again, it breaks it again, it fixes it, and it tries it again, and it gets it right. That is American genius and ingenuity and innovation at its very, very best. And there are other companies like Firefly, like Relativity Space, and others. And sorry if I didn't name your launch company, but there are some great launch companies that are building launchers that are either they're very, very nearly there, and they too will get up, and they're going to bring more capacity to the marketplace and bring costs down. And then you've got the traditional guys like Arianespace in Europe and others, and they'll work it out as well. So while there is a bottleneck at the moment, and I'm very, very glad to have our launches all booked and taken care of, And of course, you had the Russians that withdrew from the market. So Soyuz, Soyuz is not available given the current crisis in the world and the political situation. But there is a wonderful change in what I'll call the democratic world's availability of launch capacity and the innovation that we're seeing taking place. So I think launch is something where the picture is going to be getting better and better over the course of the next 4 or 5 years.
And I want to tie in something that Declan said earlier. We're talking about, the U.S. and innovation, but it was actually, German engineering that helped build the Saturn V. German engineering put us on the moon. So it really is the best of both worlds coming together here. Is you have the precision of German engineering along with the entrepreneurialism of what goes on here in the States. So it's really
and
a great team.
It was German engineers that did the selection that brought this team here together. So the German engineers have still got a lot to do with space. They're a very, very talented bunch. Yes. And that's why we've got offices in both Munich and Berlin exploiting the gifts of those German engineers and putting them to work in this sector.
No, it's a great collaboration, and you're seeing people from many different countries now, coming out there, because any country could sponsor a constellation, but at the end of the day, it's all about your target market that you're trying to hit.
Yep. Well, and maybe the one thing I would add is I actually wanted to once again reflect on what Declan said. Yeah, I think, of course, Mynaric, another German company that has been working in this regard quite a bit, and I think exactly that Western alliance is coming together. Yes, there is a made in U.S. capability that we are all going for. On the other side, we are also making sure that the Western alliance, the Western companies, the democratic countries are going to look after capabilities fielded by any of them. And there are certain capabilities we're seeing in the West that is ubiquitous to the whole Western satellite constellations. Optical comms being a very good example, very much dominated out of Germany, making the backbone of any constellation out there.
Well, with that said, from you all, let's talk about that as our last kind of closeout question. Traditionally, space-based capabilities have been limited to only a few countries, a select few. So how has technology and cost changed to where countries can ultimately sponsor their own constellations in the future?
I mean, we're seeing, if you look at just even recent events, Angola just purchased their first satellite. Vietnam just purchased a satellite. Poland just purchased 2 satellites. You're seeing, any country now even a third world country can become a space power and a space-bearing nation. It's really gotten to a point that you're seeing lots of governments being able to say, hey, we want to be part of this too. They're still trying to figure out what to do with it. But this is how it starts. They start small and then they get bigger and they want to own, you've seen people like the Five Eyes wanting to control their own comms now. And separate from the U.S. And you're seeing, but that's okay because the U.S. needs to use its own capacity for its own things, and because the U.S. has a dramatic shortage today of assets in space, which is why they're pushing data as a service. They're pushing for the commercial companies like people on this phone, on this call, to go innovate and do things themselves, and then provide services back to the DoD.
Anyone else want to comment on that last question?
I would say one of the not really just because my company is quite a bit involved in it, but I think optical comms in itself is going to have a profound effect actually on the way we utilize space. You talked about everyone having their own constellations. That's almost like saying, hey, everyone having their own internet. I think one of the things that we will see is actually more and more companies are going to put up a certain number of assets into space. But people are not going to completely close off their networks. I think what optical comms allows you to do is ad hoc networking between any 2 satellites at any given time, as long as you adhere to some standards. And that's exactly what made the internet on the ground so successful. It's not like we have that Cisco network and we have a ubiquity network. We have one network based on standards where everyone's internal networks and external networks are all tied in together to one single mesh. And I think we're going to see more of that happening. Of course, there is going to be a tremendous advantage to have a closed network when you want to, and then open up and communicate to the whole, I want to say, constellations and the whole data structure up there when you choose to. And I think that's going to play a big effect. And what that does for small countries is, me as a country that is just going into the space business, I will be able to put up a satellite into space, which is an Earth observation satellite that normally will have maybe 10 minutes of data for me. But I will be, for example, be able to drop my data off at Declan's network, and I will be able to get my data all the way back home any given time of the day. So it's almost like me buying a single computer and plugging it into the internet. In this case, it's the Rivada extranet. That capability is going to really allow countries that have singular satellite capability to actually reap the benefit of this constellation move.
It's a really interesting point that Bulent makes, because, you know, if you're Liechtenstein or you're Brazil or Germany for that matter, you can have the outer net, you can have global networked effect in not a virtual private network, an actual private network in the outer net. You can have your 1, 2, 3 satellites connecting into the outer net with that laser. You know, think about a fishing net cast around the whole planet, connecting into that and acting like a truly planetary network enveloping the whole planet. So the network effect by tapping into the outer net that is meshed this way is going to give huge reach to countries that didn't previously have it. Not just to countries, but to enterprises, businesses, and not all of them. Yes, the big businesses and government customers, but some smaller and medium-sized businesses too. It's going to change the world for the better.
Seems like it. So is there a merger of your companies in the cards?
Not anytime soon. We've all got our jobs to do, and I'll talk for Rivada here. We've got there's a great team right here, great shareholders behind the different teams and different shareholders. We've got a very committed group of. Rivada's a private company, for example, with a smaller group of shareholders who have funded, and we've just recently added some new additional shareholders to make sure that we provide the equity and structure the debt that needed to complete the whole global constellation. Who knows what the future may bring? We're a private company. We're going to stay private for the foreseeable future. And what my friends here will do, they can best speak to that.
Now, Mynaric is a public company listed on both sides of the Atlantic, and I think we are doing quite well in building up a company that is really answering this call for an extranet capability out there. A lot of companies like Rivada we are talking with who really are looking into what Mynaric is doing, and we want to make sure that we stay at any constellation, any construction, as a company that can really push that space, that new agenda of space forward, which is this confederated utilization of space. That is for us quite important.
We're public. We're good.
Well, Bulent, Declan, and Marc, thank you so much for this great discussion. It's been a fascinating day here for our Space Symposium. Thank you for your time and all of this hard work. The sky is the limit. So I've learned so much today. I'm sure our viewers are their minds are blown. So we appreciate you joining us on our conference today.
Thank you very much for having us.
Thank you.
Again, thanks everyone.
All right, everyone, what a great day we have had. Know that in just a moment, you'll be redirected to the registration page for the next conference. Stay on to reserve your spot early. On behalf of all of us at the Emerging Growth Conference Space Symposium today, we want to thank our presenters and attendees for making this such a great success. Remember that a complete replay of this conference, separated by company, will be on our YouTube channel, youtube.com/Emerging Growth Conference. Also, follow us on Twitter at Emerging Growth C. I'm Anna Berry. On behalf of myself and everybody who made this event possible today, I want to thank you all and wish you a happy, healthy, and successful rest of your week. We'll see you on here again.